Well, this is a little electronics fan, and this, oh boy, this is another one of those things that I collected along the way over the last 40 years. I have no idea where I got it, why I got it, any of that. It is a Seeburg HFMA1-L6 High Fidelity Master Amplifier. This thing maxes out at about 25 watts, is what it says in here. Thankfully, there's documentation on these, because they give you all kinds of information in the beginning pages on how to use these, and there were things I didn't know, but then I don't work with or on Seeburg stuff ever. I actually have used this. I think I set up a speaker connection here, but reading the circuit diagram leads me to believe that maybe I was doing it wrong. I set this up for use a good many years ago, and I had to stop using it because the electrolytics just had given up the ghost. It was humming something fierce. I am not going to plug it in. I know that it worked when oh, a spider remains of. I know that it worked when I put it away after the humming got to the point where I decided it wasn't a good idea to keep using it. I don't know how old this is, because you've got some tubes like this, and you've got tubes like this, so it's kind of in the middle. So I'm guessing it's a 50s vintage, somewhere around there. I've got a pair of 6L6s in here, which are push-pull configuration. There's our 12AX7 driver tube, and we got a few other things. This is a pretty interesting amplifier. They've got a lot of controls over here. I'm going to see if I can get this off. I'm afraid I'm going to have to do something about that. But, you know, I don't know. I'll have to figure out what I want to do. So, but let's us. What is this? Wait a minute. Oh. Now, because this is intended to be used as part of a jukebox, there were some things that were done to make this usable as an amp separate from a jukebox. For instance, for whatever reason, Seeburg decided that the 6-volt, I believe this is, 6-volt supply for the filaments was going to be somewhere else in the jukebox. And maybe because that 6-volt supply also supplied power to the lights and other things within the rest of the jukebox, that made sense to them. So somebody, it was not me, put this 6-volt transformer, in fact I found the tag floating around in here, a P3064 filament transformer, Chicago Standard Transformer Corp. I have no idea if they're still around anymore. But so he bought that, stuck that in here. I believe this volume control has been added. You can see the line he drew. Maybe you can. He drew a line through the center point, and then he proceeded to put things in here. The on-off switch, I believe. Whoever did this took their time to try to get things centered on the side. My younger self probably wouldn't have done that. I was at, oh, that looks pretty close. Drilled a hole and gone forward. But this guy was very particular, and he did stuff like this. Of course, then we've got this high quality case. I don't know where he found this beast, but I don't know. I don't know what that is off of. It's pretty sturdy, whatever it is. It's got two bolts on each end. And this thing is heavy, so I guess he was trying to make sure that it didn't fall out of his hands with him just holding the handle. That would not have been ideal. So let's take a look underneath. We got a big collection of dead spiders in this thing. Okay. I'm going to see if I can lift this up a little bit because I'm pretty sure that's going to be too shadowed. Oh, what was that? I don't know. All right. Let's see. I'm going to move this back a little. Put that there. Oh, that's just the lid. Okay. Now, I'd have to check to see what's what, but one of these two is an output transformer, and the other one is the audio output transformer, and that might be it right there, maybe. Oh, and it looks like we have a little choke. Now, this thing is rather interesting. I don't know what brand. What are you guys? I don't know. C-D USA. Okay. And I don't know what you are. Fast. It says fast. I guess we have fast capacitors and slow capacitors. So, bring you in a little bit so maybe get a better look going on in there. And as I'm looking through this, I don't see anything in here that's been changed. This has been added. Okay, so there's an input jack right here that's fed into this, and that's what controls the volume. And then we've got 1/4 inch connections with a cut-off wire that also feed into this. Interesting. Well, I have to figure out what he did there, whoever that was. So there's a lot of non-standard things that have happened in this thing. But the only thing that he seems to have done was basically made this so that it could be usable as an independent amplifier. Beyond that, I don't see anything that's been touched. That's a 1 microfarad. Wow. So here's an interesting question I have running around in my head. Should I even think about leaving these capacitors in here? One of the things I will do once I've replaced the dead electrolytics, you got this one, that looks like one, another one. Oh, there's a whole bunch of them. So I'm going to replace all of those, and there's one more can, which is probably on this end. Where are you? Oh, there's a bunch of them. Oh yeah, down here. 1, 2, 3. So we've got, this thing's got filtering out the wazoo. But I guess it kind of makes sense because of how they were using it. It's interesting reading through this little thing, because they talk about the different settings that you can choose, and part of that is dictated by the condition of the records in the jukebox, which I guess that makes sense. Those of us who have used records, LPs or 45s or whatever, are familiar with the fact that they sound wonderful when they're brand new, but after they've had a lot of rough use, they get pretty scratchy. So can just imagine with something like this where it's a jukebox that's getting used pretty heavily, and those records get played over and over and over, and I bet they get pretty iffy after a while. they eventually they have to wear out. But in the meantime, they have controls that can help deal with that. So I've looked under here before, and I'm kind of amazed that this thing has never had any work. Now, okay, so I wandered far afield. These capacitors, I have a feeling these are fairly high quality, probably very high quality, given that this thing was intended to be used all day, every day, maybe around the clock in some instances, and they wanted to keep the downtime to a minimum, because there was money to be made if you kept this thing working, and not so much if it was failing on a regular basis. So it looks as though these might be fairly high quality. Mallory, looks like these are probably all Mallory. I think Mallory had a pretty good name back in the day. And the other thing that this reminds me of is Fender guitar amps. There's Uncle Doug and others who work on those, and quite often they don't replace the caps. I'm assuming they do some checking to make sure all is well, and that the voltages are what they're supposed to be, but they don't replace them unless they have to. And I'm kind of leaning that way, but one of the things I am going to make sure of is that I check the coupling capacitors. I think these may be, I think these are these are the output tubes right here. And so I'm betting that those are the ones, well, let's see, this is 0.1, this is 0.05, 0.05. Sangamo. I've heard of those before. I don't recall what their track record is, if they're regarded highly or not, but I don't know what that is. I'm doing a lot of humming and just looking around. I really wish I knew what these were. They've got, it looks like a part number, and that's all it says, fast. And I don't know that I've ever heard of a capacitor brand called Fast. But regardless, there they are, they're still in there. And I remember when I was using this, the only problem that I seemed to be having with this was from here. And there's a bunch. Let's see, that's 1, 2, this is a 4-parter. Yeah. So we have 6 electrolytics here that have to go away, along with all of these, which I don't really think. In fact, I am going to fire this up, because I want to check these. I'll cut the line and check them, but I'm pretty sure that it's going to be bye-bye electrolytic. I will work on this stuff. I'll check these guys out, probably replace them. Most likely that's what's going to happen. And then I will be back, and then we will fire this thing up. And I'm not sure what I'm going to do. Well, what I think I'm going to do is I'm going to do the 8-ohm speaker connection. I'm going to short out that one pin, or that pair of pins, and get that working. And given that he's got a jack up here, which is probably, having to do with speakers, to figure that out. Yeah, interesting. Okay, it's down here. Well, I'll figure it out. I will return when I've got these electrolytics taken care of. Alright, so what I've done is I've tried to replace the things that I thought were critical which means that I replaced all of these little guys, and I've tested them. I think this one, this is a 20 microfarad 25 volt, and I think this tested out at 39 microfarad with like 46 ohms of ESR. Not exactly healthy. Most of them were pretty much in that condition. I was kind of surprised. These are Mallory's, and none of them really tested out all that well. So I replaced all of those, and then I replaced all of the coupling caps in the audio circuit, including the 12AX7, just to be sure. And I replaced this one because I was getting in here to check resistors and all that, and I was replacing that. Hey, look at this. I mean, I'm just stunned. This capacitor is that one, basically. And they're sort of so tiny. So what I'm doing is I have on this meter, whoops, except you can't see it, can you? There we go. All right. On this meter, I'm measuring the volts that are going to be put across the speaker. I have an 8 ohm 100 watt resistor hooked up there for my output. I've got this at, I think this is at low volume. It should be, yeah. And the other thing I've done is I have chosen not to put this on my variable transformer. That's limited to 4 amps. With all the tubes in this and the massive transformer, I don't know what this thing draws. I think the fuse that they put in here was 3 amps, but I'm not sure. And I don't know what's going to happen. So this meter is going to show us B+, the plate on the output output tube, not transistor. This is definitely tube. So I want to see what I've got for voltage. Now, I read something, finally read all of the notes, and on these they've got voltages circled. 390 is supposed to be the measured voltage supplied by, in this case, by the B+. The circles are supposed to be, they're supposed to be signal volts, which could mean that this, well, it depends on the way this is set up. Because of how it's going to be used, it's got multiple different coils in the output transformer, which is, this is the one you use for your 8 ohm speaker. There's the ground, and then you've got all these different connections to these different coils. And I believe this one should be the 20 watt connection, which is what I'm choosing to use. Because if you're using only the 8 ohm speaker, then that's what you're supposed to be doing. Now, this mess right here is temporary. Somehow I managed to not get the 20 microfarad capacitor that I wanted for here. So this is a pair of 47s in series, which should get it close enough to what I want. It would probably be fine if I just put a 47 in there, but I opted to do this because I had those two. If I didn't, I might have gone ahead and used the 47 anyway. But since I had that and it was quick and easy to do, I did it. So I think I'm ready to check voltages, and I think I don't see anything. So now we're going to watch the bulbs. So I'm going to say on. Okay, it's drawing a lot of current. I want to know how much current. Let's see, we want the voltage is, wow, really? 38 watts? That's because it's very low voltage, I think. Okay. half an amp. That's very low. This is low. Why are we dropping? My bulbs are fairly bright, but then this is drawing a lot of current. Let's add a bulb. Okay. And it's got all the bulbs nice and bright. But it's only drawing just under an amp. Well, let's go full bore, because I don't believe that indicates a short. Oh wow. Alright, so now we're drawing an amp, a little over 1.2 amps, and I'm kind of surprised that this isn't drawing more. I still don't see any voltage on my speaker output. Well, but I'm getting 390 is what I should have for voltage on the plate. I've got 410. That's definitely healthy. So I guess my next step is to actually hook up the speaker, which I've got sitting down here, and I don't have anything going on there, so I may have a problem there. It's been quite a while since it's been used, so I might have dirty switches or something. But let's try hooking this up to the speaker, and I have an audio source connected and ready to go. Okay. Well, whoa, 500 volts at startup. I can kind of see why they wanted higher value voltages on those capacitors. Because there is a moment in time where this thing is drawing, or this thing is running very high at the voltages. Let's see. Okay, so that. Wow. Next I'm going to take my volume control apart. That's going to be fun because I got that little strip back there. Well, that's nice. Very nice. I do recall this working when I parked it. No longer humming, which is all good, all to the good. Now, there are some interesting things though that he did to this that I want to mention, because he clearly gave a lot of thought to how he was going to use this, and he made changes specifically for making it fit his purpose. That's, I guess, what I was heading for. So let me see if I can. Oh, that doesn't work, does it? Well, anyway, I'll just hold this. So, whoops. I keep forgetting to adjust my camera. Someday I hope I get it. Alright, there's a couple of things that I want to show you that are... let me back up. This is the power. This is the transformer that you use if you're powering an 8 ohm speaker. This is the part of the transformer, because there's two sections to this, that you use if you're supplying power to, what do they call them? They had a specific term for those. This is limited to the number of watts you can supply in general. If the number of speakers that you're supplying is going to be, if the watts are going to be more than the specifications for this, they have a Seeburg power amplifier that you can add to the system so you can then drive more speakers. Oh yes, 70 volt constant volt speakers. I thought I had seen something like that. And that's basically the remote speakers that you'd be putting throughout your establishment. So, alright, well, I'm definitely happy to hear this play again. It's been a long time since it played that well. Now, it sounded a little bit muddy, and I'm guessing that part of it, well, might be the speaker, but the other part of it could be that the capacitors in the tone circuit, which I have not changed, have changed in value. Oh, so anyway, let me get back, but I'm wandering a far afield, so I've got so many different directions I could go in, and I'm not too excited about wandering off like I do, but I do. Alright, so it looks like when I start tracing down the circuit diagram and comparing it to what I was actually seeing, I discovered a few things. Is this going to be too bright? Probably. Yeah, it does. It washes out. Way too bright. Alright. This is the power supply transformer. And the way this is written up, this wire right here actually should be down here. Because that should be, because if you look at this, and I also moved this, this was up on the side of the case, and I decided that if I needed to move the case or remove the case for any reason, that'd be a royal pain in the neck. Plus, I will never use this. It's not going to happen. So I put this back where it belonged. This is where it was originally. And the way this was originally wired, there's a ground here, and these two wires are grounded. And this pair is for the 8 ohm speaker that was in the cabinet. And this part, when you plugged this plug in, it had a shorting loop on it, and it ground this center tap wire to this ground. And I was a little bit concerned about that because I wanted to primarily use this using these 8 ohm, the 8 ohm speakers. That was my original. That's what I wanted to do. So the guy who wired this up, wired it up to make sure that this is always connected to a ground. So you don't have to short this here. Now the other thing that's interesting, and this volume control right here, yes, there we are. This volume control right here, this is not what was here originally. This was added by whoever modified this. And I'm pretty sure it was not me. I don't know how he got that in there. But he did. And that's cute. Oh, gotta love him. I was just wondering, how on earth did he get this in with that in there? And what he did was, very simple, he unfolded the rivet here and pulled this part out so he could move it, and he mounted this. And then he also soldered this other end onto the chassis so we could get that out of the way. Oh, lovely. Huh. Well, I say, well. And I don't have an easy way. Well, I may have to do what he did. Release this rivet and get this to swing out of the way so I can get this out. That's fun. So anyway, but back to my point. As I was thinking about how I was using this, I was feeding. Actually, let me back up. This is designed for a magnetic cartridge. I think they said in the information somewhere. Pretty sure they said that. Let's see, constant voltage type, output, oh yes, low impedance magnetic pickup. Well, the magnetic pickups don't have a lot of voltage they are low voltage, which means that if you're going to plug something into this jack here, something that has higher output than the half volt or whatever it is that magnetic pickups put out, you run the real risk of distorting. Actually, this made me think about something else too, of distorting your sound, because you're going to be feeding a far higher voltage into that circuit, that input circuit, than it was designed for. So, I don't know why I'm using that. I actually finally got around to making a stand for this, and because it was really hard to use this, because I'd have to prop it up somewhere, and it was a pain in the neck. The units here for resistance are right down low, and if it's tilted back too much you don't see it. You have to peer over and see it, and it was kind of a pain in the neck. So anyway, I want to see what the resistances of this volume control is, and that is 50 ohms. What? Can't be. 50 ohms. 47. Okay, ohms. All right. Even when I can read it, I can't read it. All right, 47 k ohms. Well, this is interesting. I haven't really thought about exactly what it would mean to have this wired the way that this is wired. And I'm going to let you in on the secret in a minute. I'm just thinking things through. So, yeah. Okay. Let's see if my diagram makes sense. All right. I'm recording this section because I got myself confused, and I was going to confuse you, and that would be bad. So ignore everything from here down for now. The way this was originally wired was there was nothing here. All you had was the volume control, one end going to ground. This end was connected to nothing. So when you, and this is the input for the magnetic cartridge. This is the original input. So when you move your control that way, it's heading toward ground. You're reducing the resistance between here and ground. Ultimately, you wind up with a direct connection to ground, more or less, maybe an ohm or two difference between ground and there. You wind up with no signal, or very, very, very low signal at this point, which is what a volume control is supposed to do. Now, as you move the volume control away from this point, you're increasing the resistance between here and here. That increases the signal level here, and now you've got the volume that you want. Pretty standard stuff, not amazing. Now, this is kind of creative, doing what was done. I have no idea if I did it or somebody else did. What they're doing is they're basically using this resistor, this volume control is a 47 k ohm resistor. And so what they're doing is they are trying to keep the signal level from this source low enough that it doesn't overload the preamp, or the amplifier, or however you want to put that. I guess preamp is the right word. Because the circuitry from here forward was designed for this low 300 milliamp signal, or whatever that is that's coming out of that cartridge. So this is going to be a higher voltage source. You don't want to feed that higher voltage source into this because it will distort. So with this 47 k ohm resistor in there, to a degree you've achieved that, until you get to a certain point where now you're getting closer and closer to direct connection to this point, and you run the risk of distortion. Now, the reason that could be an issue is because some of your sources, for instance, my little MP3 player that I use so much, it doesn't put out the same level of signal that even the line output on a cassette player does. My cassette players put out much more power, which kind of amazes me, but that's just how it is. So, depending on what you have recorded on there and the volume that it's recorded at and so on, you may wind up wanting to crank this higher to get the volume you want. But that little MP3 player may still be putting out more voltage than this cartridge is, and you run the risk of distortion. So, how do you get around that? How do you fix this? Well, you fix that by wiring this up properly. So let's go down here. This and this are the same connection, the same input. This is the magnetic cartridge input. And so we've got basically the same thing. There's our audio, our first audio, our preamp, whatever is over here. We go to our volume control. It does the normal thing, just like we were just talking about, except now we don't have anything connected here. What I've done is I've added, and I guess the 47 k ohms in this volume control should have been a clue that I could have used this. I tried 100 k ohm resistor here first. That did not work well. I was going to put a 47 k ohm in there. I happened to find a resistor that was marked as 47 k but actually measured at 40. I got a pair of those. Somebody screwed up, I don't know how. So I decided, well, what the heck, I'm probably not going to want to use those in something. I don't know what quality they are if they aren't reading the right resistance. So I grabbed one of those, put that in the circuit, and it works quite well for what I want to do. So now I've got this 40 k ohm resistance here, reducing the signal level from these sources, which means that this volume control basically just goes back to behaving normally, and you don't have to worry about. Well, let me back up. Yeah, you can distort this thing by cranking it to full volume, probably with either one of these sources. If you try to max out your amp volume, you do run the risk of distorting your output. But now it's because you've pushed the volume levels too high, and you're doing something you shouldn't be doing, maxing out your amp. Now, when I tested this, with my MP3 player, well, actually I tested this when I was playing with this at 100 k ohm. I could max this out and feed my MP3 player into this at full volume, and it would still be basic listening volume. It was not enough. But that means that the signal level at this point was okay. So when I changed this to 40 k, this gave me the ability to use either one of those two items, my cassette player or my MP3 player. And this is probably about the right resistance for the things I'm going to be feeding into this. If I were going to be only feeding higher output things like my cassette player, then I might want to crank this resistance up a little bit, maybe 60 k or something. I don't know. I'd have to experiment. But regardless, this works, and I no longer I'm happier with this setup than I was with this. Could they both work? Yeah, they could. Was this in danger of feeding or distorting? I didn't experiment with it long enough to find out. In fact, when I was playing with this originally, the volume control was too dirty and too screwed up to really play with it too much. But I just didn't like this design. I prefer this. And so the bottom line is, I think this is a better way to do it. I'm happier with this. I have the ability to control the resistance between here and here. I didn't have that ability here, and that's why I didn't like that. So now I tried my cassette and my MP3 player. Both of them work, and they work fine. They work just the way I want them to. I have enough volume for whatever device I hook it onto here, and unless I crank the volume to a point where it shouldn't be cranked, I don't have any distortion. It sounds clean, it sounds good, and I'm happy with it. Well, first step is I got to get that volume control out of here if I can, and clean it. And then I will go from there. So I guess, well, so my next step is to replace all of these guys, because I've been testing these as I come across them in the circuit, and these are definitely better than the ones I took out of that Philco radio, the one I did recently, but they're still not good. They leak too much, and I'm definitely much happier with having my coupling caps replaced as I play with this, and it definitely makes me feel a whole lot better. I don't know what I do with things. I set things down on the bench. Oh, here it is. Alright, so I definitely have to change this. I definitely want to change that to something else. And it shouldn't be too hard to figure that out. I'll find a circuit that uses a magnetic cartridge and something else, and that will give me a starting point for the resistance I want between here and here. So I'm going to try see if I can get this out. That's going to be fun. I can see where he kind of bent things around getting that out. So this could get out of there. Yeah, and then, well, yeah, because that's soldered, that's going to be, no, it's not going to be good. I don't know if I can, oh, maybe, just maybe. Yeah. It's got another nut in there to allow it to be adjusted as far as how far out this sticks. And if I'm lucky, I can get enough room, but I don't think that's going to happen. Well, anyway, I will be back to you when I figure out what to do. Okay, well, I've gone as far as I can do right now. There are a couple of things. There's some old capacitors still in here, 4 of them. Unfortunately, I thought I had the values for those, and I didn't order them, and I don't have them. I thought I had an O2 to fit this, but it's a 600 volt item, not 400. Also have a switch going bad here. Fell apart on me when I was checking things out because there's a little bit of a crack, a little bit of a noise in this. And those are the things that drive you batty. Because you can have bad resistor. It sounds like I have a microphonic tube possibly. Now I could have a flaky socket. So that definitely sounds like I may have to replace that tube if I have one to try. Resistors, sometimes when they're failing and you heat them up, they go bad. I had one that was driving my meter nuts. When I heated it up, it went open and it cooled down. It went back somewhere near its supposed value, what it was supposed to be, sort of close, kind of. So, and I've been poking around in the areas where I just did work here, and I did it in here, and up here, and I can't find this crackle. So I'm going to pull that tube out because it does sound like it's ringing a bit. I don't like that. But regardless, these are the capacitors that I took out of this. These are Mallory's. This doesn't say what it is, but this one looks identical, and it's a fast. Never heard of that before. This says it is a C-D, USA, and this is Sangamo. I've heard of Sangamo before. All of these capacitors, every one of these different types, test pretty bad. They're testing somewhat better than the ones I took out of that Philips, which had some of the worst capacitors I've ever seen. But I think one of these tested out somewhere near being healthy, the CD. The rest of them, a lot of them failed at 25 volts when they were at 400 or 600 volts. A lot of the 200 ones were failing around 2500 or 25 volts each. 2500, that'd be a shot. These things, I thought, Mallory, of course these might not be dry type. I can't tell under this. Do I have any that tell me what they are? Probably not. It doesn't say. So I didn't see any leaking, but they're all pretty lousy. They're way over value. They've got high ESR. They're just not good. So all of these are junk pretty much. And so these 4 that I have left, I will be ordering more caps and I will be replacing those. But, so here's what I did with this. This volume control was over, I think here. Yeah, it was here. And I had to break the rivet here, move this out of the way, and jockey that out. And that was kind of annoying. And since this is an old volume control, and I may have to replace it someday, I didn't like it in that location. So I rearranged some things, moved this from, I took this over here, put that there, put this here, just so I can get to it if I have to. Because I've got to get into this further, I may not chase down the noisy resistors or the source of the noise, which seems to have stopped for some reason, because I'm going to be going into this area. We got two capacitors that I'm going to be taking out of here, and I may just go ahead and replace this one, and maybe even that one and that one. Well, that's at least a 1 watt. Does it tell me what size they are in my? It does it? Yes, it does. So I can find out what size those are. So I may order replacement resistors for all of these on this tube. This was the last area I was working in, and before I got into this area, I wasn't getting static. So I'm going to probably clean this tube socket, make sure that wasn't my problem. If it isn't, if that doesn't fix it, and I'll do a quick test on the tube. If I have another one, I might try a different tube in there. But I'm guessing that one of these resistors has decided to not be happy with what I did working in this area. We'll see. But where am I headed? I don't know. But then I didn't want to forget this. In the previous part of this video, I played this through this amp, and it sounded pretty muddy. The improvement that you're hearing, the higher end, the crispness, and all that, that's a result of me resetting the EQ on this, because I found out, I didn't realize it, that setting this to normal EQ produces a pretty muddy output, and it's possible that the music files I have on there are not so hot, but the quick fix is simply change the EQ on this. And what triggered me to look at this more closely was when I hooked up my CD player, my portable CD player, to this unit, and I saw how crisp this thing was and how nice it sounded. I said, we have a problem. So I've been playing with this a little bit to try to get it to improve, and I think it sounds really, really good now. Let's see, was I going to, I don't know what I was going to do. So at this point, oh, actually, I'm going to actually let you listen to this, but then I'm going to show you one more thing before I wrap this up. Actually, I'm going to also show you, I built this stand for my meter, and I thought I would just show what I did for those who are handy with a welder and maybe have some scrap metal floating around. I'll show you what I did and why, and then we'll wrap it up there. So let me run. All right. So we're going to go here. So that's a huge, huge difference. I also angled the speaker up so that the camera could get a better angle on it, because if I had it sitting flat on the floor, the highs were still a bit muffled because I'm so close to it. It was kind of firing past me. By angling it back a little bit like I did down here, can you see that? I don't know. There's a speaker right there, it's tilted. So as you can see, this sounds really nice. It's an amazing, well, of course it's designed for a jukebox. It's designed specifically for good sound. It's got a lot of bottom end, even with this little speaker. Maybe too much bottom end. So let me, though, show you what I wanted to. Come on, stop. All right, power off. All right, so we're going to kill this. And I'm going to flip this up and show you some of the settings in this, and they really do make a difference. I may actually show you how they affect. Oh, the other thing that I wanted to mention, I forgot. This volume control. I'm always going to school when I work on things. I just always am learning things. I think I mentioned this, but as I was thinking about this this morning, I knew I was going to go back on this and work on it some more. Something dawned on me that I should mention. Some of you already know this, and it's not going to be anything new to you. But for some people, you aren't going to know this. I had to take this apart because this was one of those volume controls, which this sucker is built. It's it's also a Mallory, 50 meg ohm. It says, oh, M, that's right, 50 k ohm. That's another thing. If you see M on older equipment as a measure of resistance, that doesn't necessarily mean meg ohms. It could mean k ohms. Why they did that back when, I don't know, but that's what they did. So anyway, back to this. This thing is built. It's got it's like a little ball bearing being pushed against the little roller bearing, pushed flat against the resistance material. It's not spinning, but it's an amazingly hefty piece of metal they've got riding against that. I had to take this cover off, had to take it all apart, and I learned from my previous mistakes on, it was the Philco. It makes a huge amount of sense to spray. So here's what I did. I sprayed the surface of the resistive material. I rotated the control. And then the design of this is such that it allows me to get to the resistance material easily. So I took a piece of soft cloth, I wiped it all down carefully, and then I shot it again with cleaner, contact cleaner. I used Deoxit, but there's other stuff I've used in the past, may use again. And then I did my analog meter test, and it looked good. And so this time when I put everything together and tested this, it worked properly the first time. And so the point that I'm getting to is, if you shoot cleaner multiple times into a control and it keeps dropping out and it keeps misbehaving, you might want to try pulling the metal case off and getting to the internals of that volume control and wiping down the resistance material and then hitting it with cleaner and then testing it again. Because that might, you might originally have thought, oh, this volume control is dead, it's junk, I got to get another one. Well, if you actually physically wipe that resistance material down with carefully, gently with a soft cloth, and then clean it again, you might find that that volume control works better. Maybe works normal like this one does. This one was definitely almost unusable. It would break up and static and just, you know, it would drop out and static and do bad things. And I wasn't too happy, and I was really hoping to not have to replace this, although this is a 50 k-ohm audio taper pot. Is not too hard to get hold of, so I wasn't too worried about that. But it was kind of nice to get that one working again. It's a high quality unit. So I don't know how much use this has had. This volume control was not the original control that came with the Seeburg. This was added by the same person who did the other modifications on this. So wherever they sourced that, I don't know how long ago they did that, but that's an old control. Of course, a lot of people have stuff floating around in their junk box, and oh yeah, I'll grab that and stuff it in and make it work and do what they want it to do. So, anyway, so I want to flip this over. I'm drawing too much, I think. Alright. Let's go this way. Yeah, all the junk is falling up. My soldered stuff. Boy, how am I going to get in there? I was going to pull this cover off, but I still have work to do on it. And I really don't want to have to worry. The nice thing about having this case on here is you don't have to worry about it tilting over and doing harm to any of your tubes. Actually, well, let me do this, because I have, yes, here we go. Maybe? Oh, there it is. Alright. I'm going to show you first of all. Alright, well, I'm re-recording this section because, well, for part of the video when I was trying to explain what this is all about, I was focused over here and pointing to stuff over here. That does not work very well. I've gotten frustrated because I do that far too often. So what I've done is I'm trying something. I now have a monitor that displays what my camera is showing me. And since I'm looking in that direction more or less anyway, hopefully I'll catch on to the fact much faster that I'm aimed at something other than I want it to be aimed at. So, with that out of the way, let's see what we can do about recreating this part of the video. Before I look at this, I want to show you this part. And we want to, alright, this is the top of the amplifier. And up here on one end is the connections for the speakers. This is the 8 ohm speaker connection, which was on the side of the case, and I moved it back to the chassis. This is remote volume control socket. Right now there's a little 9-pin plug in this 9-pin socket. I don't know if it has shorting tabs inside there to make connections. I didn't look. This is the 70 volt speaker output. This is the control that controls the amount of wattage that you're going to be supplying. If you're using the 8 ohm speaker connection, then you must put this on 20 watts. Now, there is a question in my mind about running this without a speaker attached, because number one, In this socket is originally was a wire that came in here from the center tap of your power transformer, and then on the other, there's 4 pins here. So this pin would be the center tap, this would be a ground, there's another ground, and then your 8 ohm speaker would connect. If you don't have your speaker connected here, that center tap is not grounded and you will get no B plus voltage. So the only thing I can figure is that they have a plug that you can stick in here that has a shorting loop in it that would allow you to then use this without an 8 ohm speaker, and then you would probably want to drop the wattage down. Now I don't know, the other concern that I would have is that your output transformer, usually you don't want to run an amplifier with nothing connected to your output transformer, and that's usually a bad idea, at least that's what I've been told. So I'm not sure how they do that, and I don't know if I have that information. But anyhow, I digress from where I want to get. So I want to show you this end of it, of this amp. Oh, and it looks like there was, actually, I don't know what that is. It doesn't tell me what it is. Kind of looks like an on-off switch, but I don't think this had an on-off switch here. I think it was mounted elsewhere in the jukebox. Somebody familiar with these would know, but I don't. So let's go to this. Alright. So, you've got, let me zoom in a little bit. Alright, there we are. Alright, so this is called record compensation. And there's actually 3 sections. You've got this one, and this. Over here you've got noise suppression and frequency range, and in the middle is a slide switch, and that slide switch affects both of these. And the reason you've got this is the fact you're dealing with vinyl records. Vinyl records over time get noisy, they get worn out. This being a jukebox means that the records are going to be used probably right to death. And as the records age, rather than replacing the records, you can adjust this compensation or noise suppression control downward to try to make the records sound okay, even though they're very tired. What happens, though, is that when you bring it from here down to here, you're killing high frequencies as well as low. But primarily, you want to cut back on the high frequency stuff. That's where a lot of your noise is going to live. This has an automatic volume control, I may have mentioned before. Some records are recorded at different levels, not all records are recorded at the same levels, I guess. So having an ABC keeps the volume levels a little bit more consistent, so it's not, one isn't really blasting and one's not really quiet. Then over here, these are tone controls. And these are 4-position switches. They aren't a progressive control. They aren't very like a volume control. And oh, I'm going to just mention this as I'm thinking about it. All right, this is that control that controls the wattage. It goes all the way down to 1 watt. Again, if you're using this with remote speakers, you have to be aware of the fact that the maximum wattage that you can connect to this is 25 watts. Now, this right here, I have a nasty feeling that when I was using this back in the day, 10 years ago, maybe more, I didn't realize that this wasn't really intended as a speaker, as a normal speaker output. I have a nasty feeling I was connected between ground and one of these A or B connections. And how this is supposed to work is you connect your speakers here and here, and if you have a shielded cable going from the unit to the speakers, the shield goes here. But I seem to recall that this actually worked. I'm not sure if that was the best idea. Probably wasn't. I haven't checked the voltage between the ground and B. But yeah, you don't want to put your speaker, you don't want to connect your normal speaker there. You want to go to the 8 ohm connection and use that. So, on to the regularly recorded program. So I want to actually fire this back up and show you what happens when you let's place things. No, that's not what I'm saying. Let's swing this around. This sucker is heavy. It's got bunches of heavy steel in it. Alright. And I flipped that around because I don't think my speaker wire would reach all the way over there. So this is my speaker. I'm going to have to put labels on here so I don't forget what is what. Especially with my memory, I'd do some bad things. Don't want to. You really don't want to feed in something well, actually I guess I wouldn't screw anything up. I certainly would know what that is, but anyway. Oh, so on, I think, on. Oh, I also have there's a light bulb. I don't know where that was originally mounted, but the bulb has terminated, as far as I can tell. There we go. Now, alright, okay. Okay, so there it is. Let's go back to the beginning of that. So we have the same thing. Now watch. I hope you can hear it. Let's see. You can hear it a little bit. And then that's the treble. I'm not getting much difference out of my bass control. Oh, okay. The fault might be here because I killed a lot of the bass on this because that little speaker isn't high powered, so let's bring back some of our bass. So I don't know if you could tell, but it does add more bass. So, but those are the basic controls. I'm not touching the auto volume control switch also has an impact on the sound quality. But I'm not touching that switch because it will fall apart if I do. So when I push this little knob forward, it trapped the pin that was falling out of it. So we're going to leave that alone for the moment, and I'm going to see if I can salvage that. There's a little rivet that seems to have failed and pulled apart, or pulled out. So I'm hoping I can squeeze the rivet together, push everything back in, and then press it back out again. It'll be interesting. So I think this is where I'm going to wrap this up, though. I mean, basically all I'm going to do is I'm going to clean this up, get rid of all the spider webs, get my bulb working. It needs to have a better cord. Let's turn that off before I get bit. As you can see, it's got the UL approved, wrap the wires together and tape them together. Not ideal. So, and that's basically what I'm going to do at this point, and I don't think it's going to be all that exciting. I'm also toying with building a case that will both give me access to it, but also at the same point in time protect it. Gotta get that out of there. Are you doing that? Yes. There we go. So, you know, a little bit of cleaning, repairing the label, making that stay down, and maybe some paint. And that's about it. But this is a nice little unit. If I had a better speaker to run this through, it would be pretty surprising, I think. This unit, as it said in the paperwork, is about 25 watts. And if you ever listen to some of the old jukeboxes, that seemed to be enough to put out some pretty good sound. And oh, and by the way, in case anybody's wondering who doesn't know, this is non-copyrighted music, which is why I'm using this instead of something else. That way I don't have to worry about getting nabbed if I want to play music for more than 2 seconds, which is about all you can play. So I'm going to wrap this part up. And so for those who might be interested, this isn't going to be much of anything, but I want to just show you and maybe give somebody some ideas. All right. The design of this came about because, well, let me back up. I spent a fair amount of time coming up with a design for a meter stand. So I had seen Jim, I think from Jim's Radio Shop. He had a meter stand that was tipsy, and I thought, yeah, I don't really want something like that. So I spent a fair amount of time trying to figure out how I wanted to design one of these. And I got out to the garage, and, you know, I'm one who keeps stuff around. We retired a shower caddy, a chrome shower caddy, and I thought, there's probably some useful metal in that. I'm keeping it around. My wife used to pick on me for saving stuff like that, and then when I would use some of it for the house to repair things, she suddenly stopped complaining about me saving stuff. So I got out to the garage. I started looking at the shower caddy, and I noticed something. This nice big fat piece of metal. I said, huh, I wonder, because one of the things I worried about is I didn't want this to be flippy or floppy. I wanted it to stay put. I wanted it to stay stable. So I saw this nice big flat piece of metal, and it's fairly heavy. I said, I wonder. So I cut this piece out, and my original design was going to have 4 legs. It was going to be a whole lot more complex. But I realized by using this, I could make life a whole lot simpler. So the shower caddy had some heavier rod in it, so I cut those out, welded those to this, used some of the thinner pieces of rod to make these parts. And the nice thing is that just a couple little welds in the back here, and if I were to get a meter that were larger than the one I'm currently using, and that I wanted to use this stand for that meter, then all I have to do is zing zing, get another piece of scrap, which I have, shape it to the right width, weld it back on, I'm done. So now, by the way, this has a stand. It's lousy. It's flimsy. It tilts it back too far. And if I have it back on my workbench, I can't see what the range is that it's selected when it's measuring resistance. By doing this, I can see what I want to see, and if I'm videoing, I don't know, can you see? Maybe not. Let's see. I can't tell on the camera. Oh, yeah, it doesn't quite show up, does it? Well, if I really, really wanted to, I could bend these two and I could tilt this forward. For me, that's the right angle. Of course, my camera, if I zoom I know. Let's do this. Oops. Will that fix it? Something I should be aware of, I guess. Kind of. You can see that little M slightly. Yeah. Well, anyway. If I really wanted to, it's a simple matter to bend those two rods and get this positioned a little bit more aggressively forward, which I guess I could. How far would I have to go? Quite a bit. But I could do it. Not a hard thing to do. So anyway, for me, having it angled up where it is far better than having it lying like this. Whoops. Having it lying like this. Because when especially if I have it further back on the workbench and I'm working alongside, you can just barely see that measurement. And I kind of see what happened, but because as you go through the now it really would have been nice if they had put them across the top or down the side up here, but they didn't do that. So there's a lot of stuff they stuck down here. Hertz is there, HFE is up further, so anyhow. So having it on a stand like this, it tilts it up more, was definitely the right way to go. I'm much happier with it. I find myself using this more. The reason I don't use this for some things is that because it's an all-ranging meter, it's slow when you're measuring resistances, and depending on how much measuring I'm going to be doing, I tend to lean toward the Beckman because it's a lot faster. It does take a second or two to run up or down the scale till it finally finds the reading it wants, but it does it much more quickly than this does. So I still find myself leaning toward using this, but having the stand and being able to see it, and it's just so much more stable. If I put this on this thing, it's got a round bottom. It doesn't want to stay there. But putting in this, you're not gonna knock it over. So I like that. So anyway, I just thought I would throw that in for somebody who might be handy with a welder and might have some scrap metal around. This is a design that I think back and I think how much time. Let's see, I could do it this way. I could do it that way. Oh, what about this? Then I get out there and I see this, and my plans, I just threw them away and I went this route. This was definitely a much easier, much faster, much simpler way of building a stand. So if you've got some scrap metal around like this, it would work well for you. So anyway, I hope you enjoyed this part, and hopefully I gave somebody some helpful hints on building a meter stand if they so desire. I've noticed a lot of the newer meters have stands that tilt the meter more up and down, and hopefully the bottom is flat and not rounded like this one so they don't tilt. I haven't paid attention to that part. So anyway, so those of you who have meters who are stable and sit up where you want them to be, I guess you don't need to worry about this. But if you have a meter that either doesn't have a stand, like this one doesn't, or you got one with a rather wimpy stand like this one, then this is one way to go. So I am going to say so long, and hopefully we will get together again on the next video, which I'm not sure when that will be. I do have something in the queue that's waiting for parts, and this one wound up getting done first because I thought I had all the parts for this, only to find out that, yeah, no, I don't. But there's no point in my coming back to put in 4 capacitors and say, see, I put those in, for the work I've done cleaning it up, because I just really don't think it's all that exciting. Alright, hopefully catch you on the next video. Thanks for watching.